Today, we are totally demystifying Java design patterns. Look, if you've ever stared at enterprise-level Java code and just felt completely overwhelmed, you are definitely not alone. But we're going to fix that today. We're going to treat these patterns not as rigid, boring academic rules, but as the ultimate cheat codes for your software architecture. So let's jump right in. What actually are these patterns? Well, at their core, design patterns are simply reusable solutions to those software design headaches we all face. Think of them as the proven, battle-tested tactics passed down from senior developers. They are literally the collected wisdom of the Java community, designed specifically to prevent your project from morphing into a tangled spaghetti code nightmare. Honestly, whenever you hit a structural roadblock, chances are someone else has already solved it for you. Here is our roadmap for today's explainer. First, the blueprint of software. Second, creational patterns for building objects. Third, structural patterns for organizing code. Fourth, behavioral patterns for communication. And finally, cracking the coding interview. All right, let's kick things off by laying out the map of the territory with Section 1, the blueprint of software. We're going to be conquering 3 fundamental pillars today, categorized by their core purpose. First up, creational patterns. That's all about how we create objects efficiently. Second, structural patterns, which dictate exactly how we organize those objects and classes. And third, behavioral patterns, which completely govern how those objects actually communicate with each other. Moving right along to Section 2, creational patterns, focusing on building objects efficiently. First up in the toolkit is the singleton pattern. Honestly, just think of this exactly like a country's prime minister. A country doesn't have 5 prime ministers running around, right? It has exactly 1. The singleton pattern strictly enforces that only one single instance of a class is ever created in your entire Java application. This is absolutely perfect for things where duplicates would just cause total chaos, like database connections, loggers, or configuration managers. Now listen up, because this exact question is a massive favorite in senior developer interviews. If you want to create a singleton, why must the constructor be private? Take a quick second to think about how you'd answer that. Okay, so the crucial secret here is that by locking down that constructor and making it private, you're actively preventing external object creation. Nobody from outside the class can just randomly drop a new keyword and spawn a second instance. You're literally forcing every single part of the software to use your one single verified instance. Next is the factory pattern. This works exactly like ordering food at a restaurant. You look at a menu, you ask the waiter for a pizza or a burger. You don't need to know the exact recipe, the oven temperature, or how the chef actually prepares it, do you? In Java, you just ask the factory class for a car or a bike, and the system completely hides all that messy kitchen logic of how the object is actually built. It's incredibly useful, especially in UI frameworks and payment gateways. But hey, what happens when an object is incredibly complicated to build? Well, that's where we bring in the builder pattern. Imagine putting together a highly customized burger. You don't just ask for a burger. You do it step by step. First, you pick the bun, then you add the cheese, then you choose the sauce, and finally the toppings. The builder pattern mimics this exact process in code. You just chain your configurations together step by step until you finally call .build to get your shiny, complex Java object. And right on cue, here comes another high-stakes interview checkpoint you've got to be ready for. An interviewer is almost certainly going to ask, why go through the whole hassle of using a builder pattern when you could literally just pass everything into a standard constructor? The answer? Clean code. It completely saves you from those massive, confusing, telescoping constructors. You know, the ones where you're passing in 15 different variables and you totally forget which string is the first name and which string is the last name. The builder pattern makes your object creation incredibly readable, which is exactly why the super popular Lombok library uses it. So, with our objects safely and efficiently created, let's pivot. Section 3, structural patterns, all about organizing your code. The adapter pattern is beautifully simple, and you'll see it everywhere. Imagine traveling abroad. If you try to plug a US mobile charger into an Indian wall socket, it just won't fit. You absolutely need an adapter in between. In software, it's the exact same concept. The adapter pattern makes totally incompatible systems, like your sleek modern application and some clunky legacy system or a weird third-party API, work together seamlessly without having to rewrite any of the original code. Meanwhile, the decorator pattern allows you to add features totally on the fly.
It is literally like ordering a basic black coffee and then dynamically asking the barista to add some milk and then some chocolate and maybe some whipped cream. In Java, you're literally wrapping the original object with new decorator classes to add new behaviors dynamically. Fun fact, this is actually the exact pattern behind Java's I/O streams.
This actually brings us to a really classic trap in coding interviews. Because, they both seem to add functionality, right? So interviewers will try to trip you up and ask, what is the fundamental difference between standard inheritance and the decorator pattern? This really tests if you truly grasp dynamic architecture. Here is the deal. Inheritance absolutely locks you into static behavior at compile time. Think about it. If you used inheritance for every single coffee variation, you'd end up with hundreds of separate classes like coffee with milk and sugar. But a decorator, that lets you stack new behaviors dynamically while the program is actually running. You literally just wrap the base object with whatever you need at runtime. It's a real game changer.
All right, moving right along to section 4, behavioral patterns, focusing on communicating between objects.
First up in this category is the observer pattern. Honestly, if you've ever hit the notification bell on a YouTube channel, you already understand this perfectly. When a creator uploads a new video, they're definitely not manually sending a text message to every single one of their millions of subscribers. The system just handles it automatically. In Java, when a specific event happens in the subject class, all subscribed observer listeners get instantly updated. This is the absolute backbone of things like event listeners and real-time stock market apps. Then we have the strategy pattern. Think about picking a travel route on Google Maps. Your destination is exactly the same, but you get to choose, are you driving a car, walking, or taking a bike? The app seamlessly swaps out the route calculation algorithm based on your choice. In your code, the strategy pattern lets you dynamically swap out different algorithms, like, say, switching from a credit card payment strategy to a PayPal strategy, or changing how a list is sorted, all without breaking your main application. Finally, we arrive at section 5, cracking the coding interview. Let's tie this all directly back to the real-world software you use every single day. I want you to lock these real-world mappings into your memory right now, because it absolutely proves these aren't just dry academic theories. When you use Spring Beans, you're literally using singletons. Connecting to a database with JDBC, that's factories. Lombok utilizes builders. Java I/O relies almost entirely on decorators. By really understanding these patterns, you now understand exactly how the most powerful tools in Java were actually built.
So, we've laid out the blueprint. We've tackled object creation, structural organization, and behavioral communication. Now that you know the underlying secrets behind heavyweights like Spring, Lombok, and Java I/O, you literally have the cheat codes. The only question left is, with these powerful architectural tools finally unlocked, how are you going to architect your next major software project? It is time to step up, start applying these concepts in your own code today, and just watch your applications transform from messy scripts into true senior-level engineering.